Section D, circle problems. There are certain properties of circles which involve right angles, and in this section we're going to look at 3 of those properties. The first property is angle in a semicircle. So before we can do this, we need to know what a semicircle is. A semicircle is where you take a diameter that goes through the center of the circle. So you have this diameter, and that divides the circle into 2 parts. Now I can choose any point on one side of the circle, and we'll call that point C, that makes a right angle. C will always form a right angle. So remember, notice that these are important things to know about. That diameter must go through the center, and if it goes to the full side, each side of the circle, it is called the diameter. And then I can use any point C on a half of the circle, and that C will always be a right angle, and the diameter will always be the hypotenuse of that right triangle. Let's look at our first example. Example 1. A circle has diameter xy of length 13 centimeters. Z is a point on the circle such that xz is 5 centimeters. Find the length of yz. First thing you need to do in all of these problems is draw a picture. So here's my picture of XYZ triangle. Now notice I've labeled the important pieces. The diameter is at 13 centimeters, which is my XY. I have my chord over here, XZ, which is 5 centimeters. And X, the length from Y to Z, is the length I need to find. So I labeled it X on my diagram. So since I have a right triangle, all I have to do is Pythagorean theorem. So that's going to be 5 squared plus x squared equals 13 squared. And I'm just going to simplify this down and solve for x. So I end up with x squared is equal to 144. Then taking the square root, remember we have plus or minus the square root of 144, which is equal to 12. Now notice I only use the positive because this is a distance. I want positive. So my answer is 12 centimeters. But remember, in all word problems, we have to write our answer as a sentence. So I would translate this to the following sentence. YZ has a length of 12 centimeters. The second situation we're going to be looking at is a chord of a circle. So a line drawn from the center of a circle are at right angles to a chord bisects the chord. So a chord is just a line segment that hits this circle at 2 points. So here, this line segment I'm highlighting is the chord, and my center. Now if I draw straight down the center so it's perpendicular to the chord, that will always form a right triangle. So we have right angles here. Now notice that because this is a isosceles triangle, because radii are always the same length, I have formed 2 congruent right triangles, and we'll usually just solve one of those. So let's look at our first example. Example 2. A circle has a chord of length 10 centimeters. If the radius of the circle is 8 centimeters, find the shortest distance from the center of the circle to the chord. So again, let's start by drawing a diagram of this situation. In this diagram, I'm going to label my chord AC. And my chord AC is going to be 10 centimeters long. And then I'm going to draw the radius that hits the 2 ends of the chords, and they're each 8 centimeters long. And I want to find the shortest distance from the center of the circle. Now you have to know from previous experience, the shortest distance is always the perpendicular distance. So I'm looking for the perpendicular distance from the center of the circle to the chord, which I've labeled here as X. Now remember that that line that we draw from the center to the chord always bisects the chord. So that 10 centimeters, I've now labeled each side as 5 centimeters. I can use Pythagorean theorem to solve for x. So I have x squared is equal to 5 squared plus 8 squared. So we're going to simplify this down and solve, and we end up with x is approximately 6.24 centimeters. So my final sentence for this situation would be the shortest distance from the center of the circle to the chord is about 6.24 centimeters. And the third situation that you need to know is called the tangent radius property. A tangent to a circle and a radius at the point of tangency, or sometimes called the point of contact, meet at right angles. So here, as you can see, I have my radius and I have my tangent line. Now remember, the tangent line only intersects the circle at one point, exactly one point. And where that radius meets that tangent line on the circle, that is called the point of tangency, or the point of contact. And notice here's where our right triangle is formed. We have our radius to our point of contact hitting our tangent line. And so that forms our right angle. And now we'll be able to use Pythagorean theorem to solve for missing sides of this right triangle. Okay, let's look at example 3. A tangent of length 10 centimeters is drawn to a circle with radius 7 centimeters. How far is the center of the circle from the endpoint of the tangent? So let's start by drawing a picture, because we always need to know a picture to understand what the word problem is asking. So in this picture, I have labeled the tangent segment as 10 centimeters. The radius from the center to the point of tangency is 7 centimeters. Now remember, that forms a right angle. And then the distance I want to figure out how far is it from the center to the end point of the tangency. So I'm going to label that line segment D. So it's going to be for distance. I now have a right triangle. And since I have a right triangle, I know I can solve this using Pythagorean theorem. So therefore, we got 7 squared plus 10 squared is equal to D squared. Solving this now and simplifying for D, I end up with D is equal to 12.2, or approximately 12.2 centimeters. So writing my answer as a sentence, the center is 12.2 centimeters from the end point of the tangent. Example, we're going to look at a common tangency, and that's when you have two circles in the problem. So example 4, two circles have a common tangency with point of contact at A and B. The radii are 4 centimeters and 2 centimeters respectively. Find the distance between the centers given that AB is 7 centimeters long. So as always, let's start by drawing a picture. Now this picture is going to be a little bit more complex than the others. Now notice here I have line segment AB, which was given to be 7 centimeters long, because I know my 2 point of tangencies are A and B. My 2 radii are 2 centimeters and 4 centimeters. But notice I need to form a rectangle here so that I can get a single right triangle that involves the missing side I need. So we use some properties of rectangles as well as our circle and tangency problems. Now I have a new right triangle that I want to solve for. 7 centimeters is one leg, 2 centimeters is the other leg, and X centimeters is the hypotenuse, which I'm trying to find because that's the distance between the two circles. So let's start by using Pythagorean theorem. Let's look at that triangle CED that we've just made, and we can use Pythagorean theorem to say that 2 squared plus 7 squared equals X squared. Solving this for X, we end up that X is approximately 7.3 centimeters. And that is the distance between the two centers of the circles. So I can say the distance between the centers is about 7.3 centimeters long.